systems or macro systems or micro systems, it is having an independent position, which it can be integrated and work collaboratively within other systems. Now, the capabilities, what we offer, sorry. So all these capabilities, so when you say all these capabilities are shared through the one platform, as an ArcGIS platform, where all the capabilities is given to the user or different user roles. So if you look at it, there are different user types, viewer, contributor, this all your, the user types. So all the capabilities, what is offered through a platform, it is available through the user types. So we also ArcGIS as a platform. Now this platform, it's available on-prem. You can also have cloud as a SaaS service, as a PaaS service, okay, and also now it's available in starting release in the Kubernetes as well. So let's look at the anatomy of the ArcGIS system. When you talk about ArcGIS system, primarily we look on the workflows. What is workflows here? Is the business workflow? What you say in JS, what is the workflow actually? If you zoom, that's a workflow. If you run a spatial analysis, that's a workflow. You query, that is a workflow. So these are the different way you achieve certain tasks, or execute certain tasks. So any user activity that performed on the map for achieving certain results that we call as workflow. So this workflow is complex depending upon the user needs. If you are running, for example, a drive time analysis, how many area I can reach in 3 minutes, or how many area I can reach in 5 minutes or 10 minutes. You will be running kind of some analysis, and therefore workflow will give you how many areas. It will show a buffer, this many areas can be covered. So you will be giving different types of data and so on, so that it can generate that output. So first of all, when you consider the ArcGIS platform, workflows is something primarily important. So that based on the workflow, you try to define what is the system you wanted to design. Second is the apps. Apps is what? Whatever workflow you are implementing through that apps, you are getting that benefit through the apps. Then when you consider the apps, again there are multiple information you consider. Whether it should be a web application, it should be a mobile application, whether this it need a net. If you, for example, mobile app, you need to consider whether you need an internet or not, or you can work on in offline. There are multiple things. And when you consider about the web application, it should be mobile friendly and so on. There are multiple areas we need to consider. Then, if we have workflows and apps, you are achieving through what services. When you consider the ArcGIS platform, it is a service-oriented architecture. Service means every information, every process you can achieve through the services. It's a service-oriented architecture. So whatever workflows, the workflows are implemented using services, and that is consumed through the apps from the data. Whatever data is available, so you have the different services. The services process the data and share through the apps, depending upon whatever workflows you wanted to achieve it. And where this platform run on the infrastructure. So when it comes to the infrastructure can be again on-prem. You can consider as a cloud, SaaS, PaaS, depending upon your needs. And again, when you talk about infrastructure, it includes about the hardware. Now, why we consider about the architecture here? Our own ArcGIS services, as you know, it is primarily based on the process. It's a CPU intensive process. So we consider the throughput each processor can give. That is what is accounted when you do the calculation size. Okay. So when you consider, first of all, the key part what you consider the workflows, then the type of apps, then the services, what kind of services? Because services means you have map, feature, geodata, geolocation services. So when you consider geodata, sorry, in geoprocessing service, for example, if you want to generate a site plan and every time you need, you use a geoprocessing service to create it. So site plan, so then geoprocessing service, then the type of data, when you consider the data, you need to consider whether the data should be, we continue to maintain the private database or should be an enterprise database. You need to maintain the relationship, database behavior. You need archive. You need the long transaction or short transactions. So many of the information you need to account. So all this will be considered. Then we have the infrastructure. Finally, when we talk about a well-architected framework, these are the 6 pillars to be accounted. Okay, so that means when we say I have my platform is a well-architected platform, so those 6 factors which you need to consider, which is the security of the information material, how it is maintained and communicated, reliability of the system, how fast and scalable, integrations, automation, and observability. All these factors will be considered in the later part of the slides. Now, when you consider the ArcGIS platform, it provides you, if you look at it, one of the most comprehensive help which is provided is by the ArcGIS platform. You look for any information on Google, you will find an answer for it. Similarly, when the support and the professional services all are provided to support your platform. Now, what makes a system well architected? So now I am going to define my system. How to design a system now? So first, what you need to consider? We need to consider business, right? Whatever solutions, whatever you are going to implement, it should be aligned with the business. I think if you have attended the path to geospatial excellence, I think they covered the 5 governing factors. And that factor is first one is the business. So business is assuming whatever solution you are implementing, it should be aligning with your business. So that means your end users, when you say business having a certain vision, and that vision to be implemented by certain champions. So you need to consider what are the different capability or the user requirements need to be understood well before you start your planning. Then comes to intentionality. Means what? It should be intentional. Means what? When you wanted to design a system, you need to consider this system in long run, how it will be scaled. Right? And also you need to consider that how many users currently it is to start with 30 users. I wanted to scale because I'm having this platform now currently being internal. I'm going to scale it for external. Tomorrow there could be another stakeholder which will be an external public owners who will be accessing the services. So we have first of all, if your business vision having a plan to engage the citizens or your other business stakeholders, so you need to consider that plan. So whatever you do, design thoughtfully, methodically, and it would be you should be able to ensure that addresses your business needs. Flexibility. What means flexibility here? When you consider a system implementation, the systems are running now totally. Now you feel that there's a requirement that they wanted to have, for example, a location enabling. System should easily scalable. System is already running. You should be able to adapt the change. So whatever system you need, consider for the designing. Tomorrow, if there's a need, I can have another 2 more RGS server sites, not the system, it can run independently. So the system should be fully scalable. Then best practices. When I mentioned the start section, I mentioned that Esri was usually every quarter they publish a document about the best practice for implementation. And what is best practices? Esri already clearly defined the methodology and the documentation, especially for what are the best practices when you implement the solution. Best practices means they consider workload isolation. That means environment isolation. That means you need to have a staging, you need to have a production, you have development, because you cannot mix with your production and the staging together. So that has to be activated. Similarly, workload isolation. For example, you have a geoprocessing task. and you have a routing task. Routing task means to your processing. You have a map and feature service. Your base map is heavily used, but that's again a map service. So if it's heavily used, you can keep it as a separate site. You have a geoprocessing service that runs once in a while, but geoprocessing service is a batch service. So if it is a your fork server, it needs a fork. If you have a fork process running, so you need to consider the geoprocessing server separately running, a separate site for it. So that best practices are to be considered. So when you consider the well-architected system, so define, you ensure that these criteria are met. Then continuous improvement. What is the continuous improvement? You define a system, you implemented, you started something. Now you need to keep monitoring it, how the system is used. Okay, you see that certain services are heavily used. You start adding more instances. You start because depending upon the license and the processor, you start number of instances more. Then you scale it. You see whether the usage is meeting or not. There could be memory needs. You increase the memory. But when you reach the stage, you need to scale or you need to have. It is going to gradual. It's not a gradual. It is sudden growth. Then what you need to do? You need to have another ArcGIS. So when we consider this improvement, you need to monitor regularly. How do you monitor? There are monitoring, there are different technologies available. You can use ArcGIS monitor. This will help you to monitor your service usage, the usage of the resources, everything. Monitor it, then you try to improve it. So that means what you do, that's the life cycle you need to follow. What is the life cycle? It's a generic life cycle you can look at it. First, you need to understand the requirement, then design the system, then go and implement. So this is the generic life cycle. The same life cycle we are implementing for well-architected framework. What we do in understand, we need to understand the business architecture. When you say business architecture, what? It should be aligned with business objective. It should be aligned with your number of users, different type of users, and the user workflows. When you say users, you need to understand the user types. Okay, so user types and workflows. Then the requirements, service level. What is service level? Your non-functional requirement. This is the service level agreements. That means your organization business demands for 24/7 system should be running with the 99.9993 lines. Then we need to consider the DR and other systems. Okay. Then we have to, it should be fully in compliance with your IT standards. You have the organization policy. For example, you cannot have opened the port from your web has to be in database time. So you need to comply with that. We need to have a multi-tier architecture. System should be compliant to that. So we need to consider all these aspects. Now, when you consider the design, we talk about the technical architecture. So that means first you prepare the conception. So you understood all the business needs. Now you prepare the conception. You are trying to see, okay, how the system should be. You put a logical code. Okay, that's the one system only for internal, one box. An external system for outside. You have only integration, which is heavily used, another pattern. So conceptually you place the boxes. Then what we do, we prepare a logical architecture. In the logical architecture, we define, okay, I have the system to be fully managed by my portal. So you have the first internal system with the portal and the internal ArcGIS and other components. I have a system which is fully integrated, OGC service, and I don't want to separate. I can have an independent system for that form. So those logical structures you define here. Then comes to the physical. Physical means what? Your servers, the number of cores, the what do you say? Your firewalls, your domain URL names, all that need to be defined. So that comes into physical. So while discussing the physical, we also consider, okay, what is needed for your staging, what is needed for your, okay, even for the development. You might consider, no, I just keep a simple setup in my on-prem. Whereas everything I make it as a bin at all. Or I will post my system in the cloud. That also you can take a decision there. So all this will happen in the design stage. Then what comes to the implementation. So when you're proposing a solution, if it is an organization, the first thing they're implementing, they're trying to experiment First, you prefer what you go with a pilot or a POC. If prepare a small, POC, which is the experiment system is working, they'll try to give a little more user load, yeah, it's working. Then you consider the platform that will be accommodated here, right? Then there's the normal process. You go with the deploy, test and release, upgrade and maintain. This is something very important. Your version should be every time properly maintained. We should not keep any gap because Esri periodically they ask for the operating system patches. It also keeps sharing the new patches, especially for the security aspects. Plus, there are other patches which is comes as part of for fixing the bugs and so on. So we need to ensure that the system is using and latest updated with the latest patches as well as the upgrades. Then you do operate and monitor. Operate and monitor means, as we mentioned, we can use different tools out there, especially when you want to monitor this ArcGIS monitor is the tools, one of the Esri recommended tools. There are other tools also available in the market. Now, but the advantage of Esri monitor is it can monitor the usage of the individual GA services, including the resources. Now, when we consider about this, the logical and physical design, if you are having now, for example, now 30 users now, I wanted to platform to be scaled to support maybe 150 users. We can use the user load like using the JMeter and so on. You can give the load and can see gradually the system can take how much load. Accordingly, you can scale the platform. If you look at this structure, which is business architecture, technical architecture, this all are reference to our TOGAF framework. Okay, so it's nothing new here. This is standard IT. That's what they're trying to keep everything in line with the normal IT standard. So this business architecture and technical architecture refers to the TOGAF framework. So you do the same cycle. That means you understand, design, implement, revisit, keep tuning it, and keep scaling it. Okay. Now, this is a documentation about the well-architected framework. I'll just quickly go through it. Have you ever seen this site? You've seen this site, right? Okay. So this is about the well-architected framework. So if you go to well-architected framework, they have a quick intro about a video. So it is just saying the best practice of implementation, also design and implementation. So if you look at this pattern, how they here they are clearly explaining about it's a 4-minute video. They are talking about the architecture. Now, how they have done this classification is if you go to the ArcGIS Well-Architected Framework. One second, there is a yeah. So this is our ArcGIS architecture. As you see here, we have separate architecture. You have the app, you have the service, or we can say the business time. Then we have the data tier. And if you look at it, even the data tier, you have the different type of repository. Then we have the industry standard data models. Now, if you look at this, there are information models as well. Information models means industry-specific models, like for example, UN network, even linear road linear referencing. So they have prepared some industry-specific models because that repository you can download and then you can modify. Okay. Plus, you have your own data model. You can prepare anything for whatever need for marine or for road transportation. Those models are already repositories available, which can be utilized, or you can create your own custom. Finally, all those data models can be stored in any of those repository formats, and you can also use in the cloud as well. Further, you can also have the support for the the real-time data, okay, and geocoding and so on. When you come to the service side, you have different capabilities. What is offered? Then comes to the portal. Portal is, you can know that it's a content management system where all access to your content is managed through the portal. Then you have the apps where all these capabilities, whatever is offered through the ArcGIS server, can be accessed through the apps using the different user types. So here it is just given high level about the ArcGIS architecture. Now, when it comes for the deployment, when they talk about the system patterns, so if you look at each one, even if you go to data or for the services, they are given very detailed explanation for each and every information. Now, what are the system patterns? Esri, what they did, they tried to create an abstract of different industry. That means, I think you know the 9 patterns of use for the GIS. Like, you are trying to make for the mobility, you are trying to use it for the location intelligence, you're trying to use for the real time and so on. Considering the same pattern, they enhance it. It is actually, there are 8 patterns they implemented here. In this pattern, they are trying to see how GIS generally used across different industries. So what are the components needed? That components they classify. For example, data editing. If you look at the data editing, so for the data editing, what is the minimum requirement for a certain industry that they highlighted here? And not only that, it has given the different personas and also comparison about what is supported by the individual platform. This is talking about the architectural discussions, applications. I'm not comfortable with this without mouse. That is the reason. 1 second. So actually here, I think I wanted to show that part. So there's a part of a complete table which explains in data editing capability, because there are multiple. You have long transactions, short transactions, then you have the data editing capabilities itself. So they have SCS classified what can be achieved in your on-prem, what can be achieved in online, what can be achieved in Gold, SaaS and platform, and so on. Okay. So there's a classification. Some of the geostatical, the notebook server, there are where you run the data analysis part. It can be only conducted in the on-prem. So there was a table which I wanted to show. Unfortunately, it is I am unable to access it. Then we talk about the architecture practices. Architecture practices, they heavily focus upon what need to be considered for the architecture. Something about the well-architected framework, which is the automation, reliability, performance, and scalability, and so on. Then it comes to library. When it comes to the library, we have already Esri run some test cases, and this test study with the full detail they are shared it here. For example, I want to run for the YAS network. So they prepared a complete test study. They are given the test scenarios. That means, for example, 4-core server or 8-core servers, they prepared the complete model. They're trying to give a load at 20% of users, 30% of users, 50% of users, and they've shown the result as well. So that is the consideration they used while architecting the system. So let me show that one. It is test methods and results. So they are given the physical architecture. By the way, this site also provide you to the diagramming resource also. If you wanted to download the diagrams, how to prepare a new diagram for your organization, it is giving the diagramming sketch. When what you say, those visual, stencil, which you can use it and we can prepare the different diagrams. It is given for multiple ones, visual and hydro, okay, which can be used. Now, if you look at the scene, they have given the test scenario, how they clearly explain, like how the test is carried out and what is the response time. This is the parallel service running, the parallel request running. And they are given the test results, see the test and design load. So the complete information is available on this. So let me just proceed with the. So whenever you find time, that is not find time, because if you are interested in the architecture part, please explore and visit the site. Now, when you talk about the ArcGIS Well-Architected Framework, so first we talk about ArcGIS, the complete architecture. Then we talk about the system patterns. The system patterns, as I mentioned, is almost 8 patterns are there. In these 8 patterns, we can explore all the sources like documentation, data editing, real-time data, all these information are there. So just look at that system patterns. Then comes to the deployment patterns. Because when you consider each system pattern, it also gives you an indication whether the deployment you should go with the on-prem. Okay, if you want to go with the SaaS, or if you want to go with the stars, what is supported and what is not supported. So that is the important factor you need to consider. For example, you are implementing a solution, you want to go with the SaaS. So for this architecture, okay, if it's a data management solutions, what need to be accounted? You need to consider, okay, but if I have long-term transactions, the long-term transactions, should I go with the SaaS or should I go for an on-prem? So all those information is available on the deployment patterns. They also given this the sample diagrams related. Then the reference architecture. Reference architecture indicates mainly for, it is just given for your reference. Just like we mentioned about the UN, similarly they are given for road linear reference network and even for the UN. This is primarily they are going to add more, especially for image and so on. That also can be referred. Then the case studies. So the framework, if you look at it, this is as per the IT standards. You have something as an architecture body follow. We just have some references for the various industry abstract. Then comes to the deployment patterns. What are the different patterns supported? Then comes to the reference architecture and also for the test studies. And when you talk about well-architected, we need to consider 6 factors now. Now, we'll be going in detail for each of these 6 factors. Now, let's go to the reliability. First, we start with automation. Yeah, we'll go to the automation. When you talk about automation, which all areas you can do the automation in your understanding? In your daily routine, are you using any automation? No. Have you used model builder? Yes. So that's an automation. Right? When you are running a model builder, you're preparing a particular task, a repeated task. There is an automation needed wherever you are doing a repeated task. Then, anywhere else are you using this automation? When you develop a solutions, if you want to deploy it, because the certain patterns to deny parameters, you can it automatically. You upload the code, it will go on automatically. The workflow will be using it. Then, anywhere else, you are using automation. We are using integrations, right? Integrations, we do automations. We have webhooks, which usually every people use, especially for the integrations. Then, for the deployment, for ArcGIS enterprise deployment, we will use automations. Yes, we can use Chef or PowerShell and so on. So automation that's an industry standard. So we are having this automation also in applicable to our ESRI platform also. So when you are considering automation, first of all, we need to discuss, when you start discussing, because this is the same life cycle. Understand, design, then implement. Now, in the understanding stage, which all need to be involved for the automations. That means when you meet the business team, you need to understand, first of all, the engineers, developers, we need to involve, they need to understand that these are the areas you need to automate, that you need to identify and tell them this is the way to be implemented. Then cloud architects, because if you're going to implement in the cloud, they need to understand, okay, cloud automatically is already providing an ArcGIS Enterprise Builder, which will help you to automatically deploy it. But if you're on-prem, you need to use Struts or PowerShell, so they need to be there during the discussion for the automation part. Business leads and analysts who will be designing the solutions, especially for the integration part, the groups, this business need to be identified. Similarly, the other end users, the power users primarily for preparing your processing tools or model builder and so on. So all the team to be involved on the beginning when you start doing the designing or building the capability of the system. So where we need to consider for the automation part. So we'll be involved on software part development, that is from the beginning. Then our normal power users during the workflow identifications. In the workflow itself, there's a business workflow as well. As you know, like there's a workflow server is also available. So that can automate your complete the job processing, including data collection, till posting the data into the system, we can use the automation there. Then once you implement it, again we need to revisit it. Again, where we can optimize it. So in well-architected system, what is the best practices? Focus on opportunity. That means don't try to do automation in everywhere. Wherever is needed, there only implement it. Don't try to automate everything. Okay, that might bring some of the practices also. Okay, so just look for wherever it will be implemented. So we can say where the user consumption is more. For example, you have the images. You are trying to identify certain informations. We can use the object detection or AI-based approach to extract the information because it's going to be taking a sensitive time. So identify those areas, then implement the automation there. And especially improve quality and productivity with ArcGIS and Python. How you use ArcGIS? No. ArcGIS is heavily used that can be applied both in the web as well as in the desktop. That means if we wanted to do certain calculations by inserting, for example, if I want to trigger certain jobs, actually there are a couple of cases. There's one case, like for example, we have an integration where it's a property integration. So the customer start updating the property, even the property was leased, and it was updated in the system. They started giving the contract, the was created, but the GS was able to again creating the modify the features. Because the property is leased, then it should not be allowed. So that's the case where we use the ArcGIS and it was very effective. That means once the property changed based on the business property value, the particular field value, we can control the feature editing capability. Okay, so there are many such capabilities. It's very simple one, it's a simple case. I'm saying very useful cases we can implement using the ArcGIS expression. And ArcGIS expression, not only from the ArcGIS Pro, you can also implement in your staging. Even how you symbolize the features using the web map. That also can apply there. Then we have okay, the first point. The below points are this first is the mandatory ones. The below one is a notice. You should not do it. Don't overdo it. Means they don't want to automate everything. Try to do whatever is needed. Then the groups actually you will be already using it because that's an industry standard. The groups will help you for the integration whenever you want. It is just like a messaging system. The banking system, like when you do the transactions, it goes to the queue. Previously, now it's changed now. So it was switched to the queue. The queue will keep monitoring it, and whenever it's content, it will update you on the information there. It's like a asynchronous point. So it works the same way. Whenever there's an update, the data update, you update it done, the figure is updated, immediately it will push the updates to the external systems. Ensure the observability of the automations. Whatever automation you are doing it, you should be able to observe it. You should be clearly audited. That means if I'm doing a PowerShell for ensuring the ArcGIS Enterprise, you should be able to audit the information which is going in every stage. Okay? If something is built, maybe when you start running it again, then you'll have issues. Then read the workflows, what is needed. Now, let's go to security. This is an important factor, right? We consider security even starting from ArcGIS authentication, when data sensitivity, if you have some confidential data, that you need how to secure it and you need to maintain it. You might encrypt using PDS and so on, right? So security is an important aspect when you wanted to transfer data, whether you are hosting in on-prem or in cloud, when you are using a custom solution, if you are integrating with other systems, everywhere the security, because you have credentials, which is keeping the control on your data or information you access. So how to who to involve this cybersecurity team? Because in every industry or every corporate, they might be having, because depending upon the big company size, they will be having the different segment or different departments will be handling the security. There could be maybe one team to have architecture, they'll be considering all together. In certain cases, they have a company building policies where they separate cybersecurity team who will be managing the security aspects. So you need to involve them from the beginning of the designing of the system. Security and network architects, that means the data transmissions. We have an implementation where we have a what's a explicit cluster. That means it is connected to a dark fiber. So there are two data centers. One are seamlessly connected, no network latency at all. Data centers, there's a distance almost like a 10 to 20 kilometers. Okay. Now they consider dark fiber connectivity. Dark fiber means they consider a subscriber network, like in the SLR, they are having the big network cable, I mean the network fiber cable, only to connect their two offices. Okay. So we had that implementation, but one of the concerns we highlighted was the data security part. So they are already having a separate both end-to-end encryption, which was ensured for every data. So here what happens is your one RGIS will be in one data center, another RGIS will be another data center. Because there's no latency. They don't keep all servers in one data center. Considering that they are. Then identity management. Your organization will be using your Active Directory or different IAM or different identity management. So consider how secure it is and how it can be used for your organization or authentication. Team collaboration team. Collaboration team means you need to consider all the team. Your infrastructure team, your security team, your Active Directory and who are managing the system team, including the servers and so on. Okay, so all need to be considered, especially for when you discuss about your designing, because it's all part of our designing. We are actually talking about the consistent design now. Okay, then when you involve them, there should be there in the early stage when you start considering the system. Then so continuously, this part is continuously. If you look at it, have you heard about the trust.arcgis.com? Trust.arcgis.com is about Esri releases all the security updates through that trust.arcgis.com. It's again just like architecture. Let me just open that one. All security related publications are published here. Okay, and what security policy is still following while releasing every product, that are listed here. So you can see there are so many documentations. Certain documentations are available for public. Certain documentations only available to the customers. They have to log in, then only they can see it, because you need to have customer ID, and so that you can log in and they can access it. There are many security documents. If you look at it, one of the main part they highlighting is the hardening guide. So after implementing your ArcGIS enterprise, you use an hardening guide to strengthen your security of your system. And what all parameters you need to consider, what all security aspect you need to consider, and how to apply it, that is clearly mentioned here. See here, everything on the cloud, ArcGIS enterprise, desktop, and even mobile. They mentioned, and there's an ArcGIS security advisor. You can use this tool if you're connected, your ArcGIS enterprise connected online. You can use this tool to analyze your system and identify what are the issues. It's an online tool. Okay, so there are many documentation also. See, you can see all documents here. I think certain documents you need access. See, all those documents about the new information, what is about the security threats and so on. So please explore this document if you're interested related to the security part. Because Esri, the information what they're sharing into the through the network for customers is very huge. So you need to go and explore. There are not many information. And every releases new capability. That is very huge. Now, when you consider the security part, so you need to consider, how the well-architected practice. It is, with the identity provider, data releases and patches, review your security proactively with involving the team. That means actively your team to be involved and to validate it. You need to keep checking the security check for your system. Okay. Personal important certificates because currently from 10.8.1 or 10.9.1 onwards, Esri ensure that is HTTPS, no HTTP connections, only HTTPS and TLS 1.2. So we need to ensure that the certificates are updated carefully. Least privileges as before. That means when you start, give only privileges like a viewer. Then, depending upon the needs, you just adding the new capabilities. Integrate carefully with the third-party tools. So that means don't try to open any database connection to connect to the system. You have a third-party system. You want to integrate with your system. You don't give direct database access. Rather, give access through the API, which can easily control and properties. So that access to the service, because the service, even if somebody access it, they don't access using the token. Okay, so ensure that the token is secure. And go for the privacy and compliance. This is talking about the password.com. Now, integrations. So integrations, you know that whenever we have the integration part, we involve the business, IT teams, solutions, data architects, because we need to consider both parties, not only us. The GS is going to either that system is going to be geo-enabled, or we are having a bidirectional integrations. We need to transfer the data among the systems. In that case, we need to consider their architects, their application engineers, we need to consider our other architects, our engineers, so that we sit together to try to understand what information to be shared, what because that system is maintaining a confidential data which you don't have to maintain here because that is secure in that system. So you need only that information when it will be accessible. So that access will be controlled from our GIS. Similarly, developers, engineers, then the other technology providers, those third parties we are integrating with. And their involvement from the early during the requirement stage, during the integration. So when you talk about the during integration, test and apply, we need to consider the best practices, which is going to be we have separate staging, nothing will be on production. Something will be developed, will be in development. But something to be tested on the staging means we will do the staging, then we see production. Production is not used for any testing. Your user product to be given on the staging itself. Then we have to the external system changes. Yeah. When the external system changes happens, because we might be using some APIs integrated. So we need to ensure that SLA to be maintained. That APIs are not affected because of the new changes implemented. That will affect our system. It will break our system. Right? So when you have a tight integration, we need to ensure that. Or it should be a loosely coupled integration. So here is some best practices. Integrate support carefully what, why, and how. That means what, why you need it first of all, what you wanted to achieve, and then it comes to how. So you need to clearly segregate what information should be maintained in your system here and what information should be maintained in the other systems. Existing platform for tools, if anything available, you can use. There are, like third-party, integration bus. If something is available to support your station, use that one because there's no direct integration to systems. Then respect your existing constraints what is available there. So there's something real-time versus scheduled integrations. What is the real-time integration? As soon as you update, immediately it's reflected there. Scheduled means you run periodically. So in which case we can use scheduled one. If there is the information what you need, it is not that frequent, you can go to the schedule. Schedule will help you to reduce the user load on your system. And the real-time integration, there is a huge update happening. And every time when you do it, this all will be a query and will be hitting in the system. So rather than feel that this information to be there for the system, maybe end of the day, I can wait for one day, just once in a while only reactive. They can consider for a schedule. And schedule means in non-peak hours, the system will push the information, so pull the information. Then stats will monitor hardened workflows over time. So you need to review your workflows. You need to see whether because you can make it very smaller or every time. As workflow means data between workflows. Okay, so you can see whether it's a long time or a short time. Then accordingly you need to optimize and use it. The rules which I already explained. Use client libraries for external systems. That means if SAP is providing an adapter to use it. Use rather than you create your own APIs to communicate with SAP. Because SAP, when they create an adapter, they consider all the security aspects into it. Okay. Similarly, Maximum, IB Maximum Station, they provide an adapter. So when you use Maximum Station, use that adapter to use it. Rather than you create a custom API to integrate it. Because that is more reliable than the other one. If there's something available, use that. Observability. Observability is what? It is about monitoring your system. Monitoring your non-release system, your services, your platform, the database, everything has to be monitored, including the server. Everything has to be monitored. There are different systems used for monitoring. ArcGIS server and all the capabilities we discussed, ArcGIS monitor can be used. That is one of the best tools to be used. For systems and hardware, there are different solutions available, like managing. There are many systems available, which can be monitored every communication through the network, throughput, what are transactions goes, what is the number of bits are transferring, all this information can be monitored. And when is the peak usage, when is the less usage, what is the resource utilized, everything can be monitored. So all this information can be read, and that can be actually what you do. This all information can be effectively utilized when you wanted to analyze and wanted to scale the platform. Or if you wanted to, for example, you are expecting that one service, we had one case also. It was one case, service was used. Normally, the number of requests coming almost 300,000 requests almost in 2 days, 3 days time. Now, what happens is suddenly we notice that one night that service, the request will went up to almost 900,000, and that's only for a few 2 to 3 minutes. And the service down. Okay, but luckily the service was running in a separate ArcGIS server site, so nothing else affected. Only that site is affected. But you immediately bring it back. But the point is, we need to consider. So you have a clear monitoring of the system, all the services, irrespective, because you see that the usage is now it is 300 days. Suddenly it's improved without any reason. That means something is lacking. Okay, so keep using the observability of the system. So, who to involve the resources team, operation team, including end users. End users, why you need to observe it? Why you need to observe the end users? See their behavior. Yes. What kind of pattern they are using it? Okay. They might be using only, they have maybe 10 applications, they might be using only 2 tools. Then whatever other services we are deploying, even with the widgets, it might not be in use. So we can remove that gradually. We can make it as duplicated. And if you see there is no more usage for another certain period, maybe 1 month, 2 months, then you can remove it. Part of the application model. Correct. That is what. Why you maintain it, why you have to keep it and do maintenance and upgrade and yes. That is not used. Yes. And also to give the business, I don't know how many businesses are following that. Like
even the utilization of this, it's minimum, then you can look for another alternative way. Like maybe you can get it by service provider, which is just a fraction of maintaining this one.
Yeah, but there is actually that means optimization, more optimization, resource optimization. So this has to be considered. So when to involve them during and after logical component defined. Logical component means you define the conceptual model, you're trying to define your logical architecture, ArcGIS enterprise, okay, with, for example, ArcGIS enterprise standard on the base, ArcGIS enterprise advanced because they have a routing capability. Okay, I need workflow user type because of the mobile users are there. So all this defined by defining it, you need to consider this end user stream. The infrastructure team is needed, especially when you consider the physical architecture part. Now, your logical components, when you define it, that defines your what is the capability needed. During that period, we need to consider the end users primarily. Then we have after a repair based on the student. This is the same iterate design. We have again the well-architected make use of the existing monitoring solution from your organization. If something is already available, you use that one. Incorporate observability and logging. Logging by default is provided by ArcGIS Enterprise. Every service, every application is logged, but it is not user-based. It is based on users. This is going to gradually include the user-based. Okay, so that has to be on grid. Use observation of the inform actions. You have this observability, then try to highlight the team that the service was used, but I'm not seeing that any use for it. For the service was very minimal use, but now I can see a drastic improvement. Why is the reason? So you need to inform them. See, whenever that usage is there, you need to inform and take further necessary actions. ArcGIS Monitor is something one of the best tools. We have been other multiple customers, they are using it, one of the best tools to use it. Performance and scalability. So in performance, we need to consider this is actually we can say a non-functional requirement. Okay, that means when we design the system, we consider key capabilities are something number of the response time. For example, I wanted to access my application in 1 second. That's not possible actually. Okay, so the Esri having a backend, they consider 3 seconds is the average response time. We're considering in a minute 10 user actions. That means a user sitting on a computer, he can zoom, okay, perform an action. Then there is a 6 seconds to wait. Then the next action is in 10 minutes. Sorry, in 10 seconds. Okay. So 10 display per minute. That is the Esri calculation. That is the default standard. Because it's a map. You request, that's a process service time, new time, then you show the results from the map. Okay. So the response time we consider for average 3 seconds. But if it's a batch process, it will be a little more. Okay. Now, when we consider the performance and scalability, you need to consider performance-wise the kind of application. For example, when you have an integration system, because this is for map entry. But if you want to ingest data or retrieve applicable to data, then it's too fast. It won't take on the second. Okay, this is only something rendering on a map I'm talking about. Now, who to involve in this infrastructure teams, your operations team, your architects, then the end users and clients. Who define workflows? Your end users and clients, right? Then who will define what type of apps is needed? That's again end users. Okay. Then what is the role of architects here? They need to consider what are the capabilities based on the capability to identify the components and what process, whether we need to have this environment to be separate, depending upon what kind of user load, or this to be done by the architects. Operation and infrastructure mainly for the servers. So, as usual, you need to involve them in the early stage, during defining the machine. That means first test staging side, then after implement it, then during the iterate side. So this is a practice for it again. So you need to have a measured baseline. That means what you wanted to achieve, within how many seconds you wanted to achieve. Regularly check for performance for the degradation. If it is a perform degradation, you need to regularly check it. Design to scale flexibly. That means what? I define an ArcGIS enterprise system. I want to scale tomorrow. I can have another ArcGIS enterprise system. Means another ArcGIS server side. I wanted to have a real-time data updates or what is it? Yeah, real-time data. So that means I can have a Jovan server with the 3 nodes, and I can scale with the maybe 5 or 3 special data nodes. And I wanted to have 3D. Okay, it's 10.1.4, then you consider objects or no more system. So I can go with a cluster, or I can go with a either cluster, or I can go with the 3 nodes. So those kind of considerations you need to be in place if you wanted to scale the platform. And consider when you're going for data store, if you're going for spatial or the data store, consider sufficient storage more than the memory. Okay. Yeah. So then you see the distributed experience performance from the measure. Keep monitoring it, then enhance it. Okay. Reliability. What is the reliability picture? Reliability comes in, especially when you consider this is the integration of the systems. And if you have a business system which is running 24/7, you need to have an SLA where you ensure that the system is fully reliable. So sometimes people will offer a DR, the first recovery. So you have the prime data, then you have the DR, then you have a regular, backup and restore. Here, one important factor you need to consider is the GSDR. Take backup and restore, and you can define the backup cycle for the GSDR, whether full day one, then incremental, then every week one. That all defined depending upon your RPO and RPO. Okay, so consider if you are considering a reliability, if you have an expectation, a high level SLA, which is 99.999, then you need to consider a DR. Not really. So not necessarily not forcing you to have a high level system always. You can go with a single node as well. As long as that single node can meet your business workflows or business needs. I have only 3 services and I have only 10 users. Not necessarily you need to have a separate server, one more server that have high level, because that particular server 4 can handle your 3 services, that's what it can handle. Unless something went wrong and your business having a demand, okay, even if it's for 1 hour is down, if you can bring it up, it's okay. I can go with a single node. But considering the scalability, you need to consider distributed deployment. One, that means the product will be in the separate machine, portal to be in a separate machine, artists will be in a separate machine, data will be separate, don't merge it. Then, and again consider when single node deployed and single deployment, consider a storage, you can easily map it. So tomorrow, if you want to add one more ArcGIS node, I have already the storage configured. I can add join one more ArcGIS on the same site. I can easily scale it. Tomorrow I want to have one more ArcGIS site. I can have 2 more. I can 2 more ArcGIS server. Then federate with my portal. So without affecting the current one, easily can be scaled. Okay. And SLA is high. Consider depending upon RPO and RPO, consider for DR as well. So we're talking about the workload separation, reliability approach in lower environment. Lower environment means you have the backup environment. When you talk about now, so we consider the different factors or pillars while for designing the well-architected framework. Now, when it comes to the physical design, build a strong foundation. Now we are going to define the physical architecture. So build a strong foundation. Ensure that whatever you implement, considering that will meet your current needs and easily scalable. A strong foundation. You have properly distributed deployment. If you are considering for a high available, yes, and because depending upon your business requirement, then easily can be scaled. So that whenever needs and it address your all different user type needs. Then plan for flexibility that I already mentioned now. Easily should be scalable. Then to each its own means what? Keep a separate RGL server site if needed. That means you are having an environment for workload isolation. So you have something for the base map, you're keeping some user services something for different others, say for a batch process and so on. So any load on the server, it will not affect. You want to update a new patch release only for the geoprocessing, I can update here. You have an image server, I have a separate site, image raster, 3 nodes with the raster store. If you want to scale, easily you can scale it. It will not affect any of your other environment. Okay, that is again depending upon the node need. You can have again, you have 3 other servers in high available. The fourth one, which is image, can I go for single? Definitely can go single, no problem. Yeah. Think differently. When you think differently means previously what do you do? When we do sizing exercise, we prepare what is the how many server head, what is the number of user load, how many users are going to access it. That is our question we used to ask. How many services we need to host it, which is the heavily used services, what is the throughput we'll ask. Then we start defining a base plan, right? Now systems are flexible. Now we have to Kubernetes. So what happens? We start with small because your requirements are dynamic. So consider the scalability. So keep adding whatever is needed. So start with small, quickly what is accessible, you prepare that one, but that will be a strong foundation that must be there. Then you scale as needed. Okay. So identifying again coming back to the workflow part. First of all, whenever you design your architecture, you consider the logical part, conceptual, logical, physical. Now coming back to the workflow part. H1 is user driven. That means you need to identify who is the actual user, how they are going to, what kind of workflows they want to implement. You need to identify, for example, the user is repeatedly doing a certain task. You need to tell them that this can be automated. You can use the job processing model so that you can focus to its productivity can use somewhere else. So consider all workflows to be user driven. User has to say, actually, if you attend the top session, there's a case how you write the requirement again. They'll say user story. As a planner, I wanted to achieve this. That means that person has to define what the story you wanted to achieve, what is the objective, what is the outcome you wanted to achieve. Okay. So try to define your all your workflows are user driven. Focus on workflows that the users will complete because they need to achieve the results. Foundational. Identify the workflows which is core in need. You don't try to, as I mentioned it, don't try to give all the workflows to be into the system. There are certain workflows you cannot even implement it. Even if you put effort, even if you implement, when the user is only one user, you don't have to. Okay. So try to see what is the core and the foundation ones that you need to implement it. And be specific. Okay. So when you define the workflows, it should be very clearly specific. And it is precise. That means you need to get it well defined so that you are following the right path. So that when you troubleshoot it, easily you can be troubleshooted and you can resolve it. Standardized. If you can look at it, Esri is already offering some standard workflows. There are many workflows. So you consider that while implementing it. You don't have to build everything from your side. There are many available. Test and improve. Then utilize and improve it. So saying workflow. So we consider the business architecture, the technical architecture, implement, and research. Now, just we are trying to say how we are aligning with our journey with your organization. Here, what we're talking about, your business, you started something, it starts evolving. There are new acquisitions, you have new branches, they start scaling, right? So, with your systems also, what you need to do, it will be initially small, you start scaling. You're having more workflows that will be implemented. So that means, along with your business systems, your systems also, your GS or your spatial systems also, they have to be involved with it. It may be one system or it could be multiple. There are organizations, they will be having one system. There are organizations, they have multiple RGIS interface systems running from different departments with different objectives. So there will be portal to portal collaboration that also can be implemented. Now, so what you say, business they have different business visions. Okay. In line with that one, you have the geospatial system to be implemented. It should be both aligned. So as the business evolves, the geospatial also should be evolved. So this first session was covered in the today morning. That's a part with geospatial aspect. Okay, so when you talk about the business, there are primarily 5: the business, the governance, system, capacity, and engagement. What you have the business, I need to have a proper governance of the information that has to be there. Then comes to the systems. You have multiple systems. This system must be able to collaborate each other in aligning with the business vision. Then capacity. What is capacity? It is especially building the skills. If you wanted to have strong support for your business, why the geospatial team? They have skills to be genuine, develop their skills. You need to help them, reward them, you need to educate them so that you give an opportunity for them so that they can use their insights to align with your business objectives. So when you talk about your geospatial journey, along with your business, your framework also to be evolved. Thank you.